Shooting. Okay, that's pretty good. Well, they didn't shoot at all. All I did is I added those 3 lines. Hello, and welcome to Game Revolutions, the series where I write a Moon Patrol clone for my Coco, using nothing but assembly language and my ever-diminishing wits. And you get to see all my fails. It's been a while, so let's do a recap. We started with a series where I dug through my original files from high school when I first started coding this game, and figured out how to get them running again. Then this series began, where I added double buffering, stack blasting, self-modifying code, improved animation, optimized scrolling, optimized joystick reading, data-driven level encoding, jumping with simulated gravity, rocks, crash detection, hit detection, enemy attack formations, and much, much more!
Now how much would you pay?
Today, those alien Feeblas learn how to defend themselves, and rain bullets down onto our player's car. As you can see, the video is only 5 minutes long, so things must have gone very smoothly. What? That long? And I learned a lot of life lessons along the way? It's the journey, not the destination. I have a draft of the code ready to try out, and I'm going to go over the highlights of that code with you. The thing I'd like to try is to make use of code that I already have. So I have this routine handle car bullets, and it's capable of dealing with the animation and the hit detection for the horizontal and the vertical bullets. The bullets are represented in memory just using this struct. This tells us whether it's horizontal or vertical, where does it live, and these also say where it lived. These are useful for hit detection. For horizontal bullets, this says which bit pattern I'm using. And then finally, how much longer does this bullet have before it runs out? Why not just make use of the same bullet info structure, make use of all that same code, and just add more instances of this for bullets that the Feeblas shoot? So the storage for all those structure instances is right here. I have a constant that tells me how many bullets the car is allowed to have in flight at any given time. Now I have 2 constants. One for the car's allotment and one for the enemy's allotment. So I'm using some more memory, but it's the exact same format of memory, the exact same structure. And for now, I'm leaving the car bullets as it was before, 8, and I'm having the number of enemy bullets be a max of 4. I think any more than that might be too tough to navigate, but I can change that anytime. And I've added a new constant for the type field in that structure. Before it was just horizontal bullets and then vertical bullets. And now I'm distinguishing between vertical bullets for the car and vertical bullets for the enemy. I'm letting both of these remain positive because they will share some of the code. So the code that goes through each of these bullet info structures and animates them will check the type of the bullet here, and I'm still using this right here. If it's 0, that means the structure is unused. If it's positive, that means it's a vertical bullet, otherwise it's a horizontal. I didn't need to make any changes to this, or really to almost all of this routine, for it to just handle the bullets from the enemy that are coming down rather than going up. The part that does change, obviously, is figuring out when I animate it whether to make it go up or down. And so here's where I really need to compare that type with whether it's enemy or not. If not, this sub 64 will make the offset go up, because it's coming from the car. Otherwise, I will add 64 and make it go down 2 lines. So let's take a look at the code that actually creates these bullet info instances. I have a large routine called draw Feebla. It's responsible for drawing each individual Feebla, erasing its old position, and drawing its new position. I just added some code to ask, hey, should this Feebla shoot a bullet? And so yes, there's a bunch of code here, much of it quite similar to the car shooting bullet routine. One of the differences is we use random chance to decide whether the Feebla shoots as opposed to looking at the button on the joystick. Get random bite is that random EOR routine that I showed in this video. I chose this way of generating random bites because it is so doggone fast. The issue you might recall with it is that it does generate a repeating pattern. After 256 numbers are selected, the exact same sequence of 256 numbers will be selected again, and then again, and then again. It has a period of 256. But for a game, that shouldn't matter. I also did a bit of Simon Jonason magic. I added some self-modifying code so I could take advantage of immediate mode addressing. So now I'm storing my seed not in a separate memory location, but inside the instruction stream itself. This is where I'm storing my seed. And so the code to write the seed back happens here. Otherwise, for more details, check out this video. Now in that video, there is some code that talks about how to change the range that it returns. Instead of being from 0 to 255, you can make the range be whatever you like. The key part of that range adjustment is this multiply instruction. It multiplies the maximum of the range by the number that was generated, and then we use the high byte as our answer. I talked about why that works in that other video, but I didn't talk about the fact that multiply does take a long time. That's 11 cycles just to get it in range. So for example, if you wanted something to have probability 1/3, you'd have your maximum be 2, so that your possible values are 0, 1, 2, and then you do something like a branch on equal with the result, because if it is 0, that will happen 1/3 of the time. That makes the calling code easy, but at the expense of doing these 11 cycles every time. Instead of that, when I call this, I just accept it's always going to give me something between 0 and 255, and I use probability thresholds instead of individual numbers. If the number chosen is lower than the threshold, then that means that the event that I'm testing for has occurred. In the code you're looking at, we're testing whether the fiblosh should shoot, so I'm actually checking if it's higher than, and if so, I'm going to skip the code that has the fiblosh shoot. So I'm just doing about 5 cycles for both the comparison and the conditional branch. For now, and this is temporary, I make the probability that the fiblosh shoots 100%, and we'll never get a value back that's higher than this. And the idea is that I want to be able to see with reliability fiblosh shooting, reaching the threshold of how many bullets I'm allowed to have at a time, then having the bullets stop for a while until they disappear. I want to be able to see all of that. Then I can fine-tune this later, but for now we're just going to have them always shoot whenever there's room for more bullets. So assuming there is, I have code that's similar to what I had before, but just with some new values for the fields. So I have a different bullet type. I'm basing the initial offset off of where the fibla lives, not where the car lives. I calculate the column byte and the row byte, and I figure out how long the bullet will remain in travel based on its height, and dividing by 2 because it goes down by 2 lines each time. Alright, I think we're ready to see the code in action, which is to say, watch it crash and burn, because that is what always happens the first time I run my code. Alright. Okay. Alright, well this is better than I expected. Bullets are raining down, but they're not coming from the fiblas. We've got something going on in the sky. But we actually have bullets coming down and disappearing at about the right time. You'll notice, by the way, I have all of the crash detection turned off, and I have auto jump turned on. This is from before. Let's watch them come out. Yeah, they're coming down from... Okay, we'll have to figure that out. Okay, I found a few things, but one in particular I am pretty sure is the main culprit here. This is that code where I'm initializing the new bullet info structure, and I'm figuring out what to put in for the initial offset. This, I think, is why the bullets were raining down from the sky instead of from the fiblas. Do you see a problem with this line? Old, new, old, new. Do you see what I changed? I make this kind of mistake all the time. When I'm using immediate mode addressing and the argument is just a constant literal number, I don't usually have a problem remembering the pound sign. But when the argument is an equate, a symbol, for whatever reason, I keep forgetting to put the pound sign before it. So rather than adjusting the offset for where the fibla's offsets begin, I was going to the memory location of this constant number, which was some small number, somewhere very low in RAM, and grabbing whatever random byte was there. All right, there. Okay. Let's take a look at that again. Maybe I just had bad luck, and I just need to run it again. They do come from the right... Okay, and then... All right, so they hit the ground and I got weird patterns there. And then we aborted. Okay. Okay, I found something. Definitely needs to be fixed. I don't know if this is responsible. And I don't know how I made this mistake. But as I said before, in order to figure out how much remaining travel we have, I figure out the height of the bullet, and I divide by 2 because it's going down by 2 rows each time. But how did I actually calculate that? I took the bullet row and I negated it, which is good. And then I just added it to the rest of the formula, including that divide by 2. I'm supposed to divide by 2 after I add it to that part of the formula. So I think my remaining travel value that I've been storing here has been completely wrong. So wrong as to keep these bullets continuing to fall well after they escaped out of the screen buffer memory and into something else. So the new code negates the bullet row, adds that part of the formula, and then divides the whole quantity by 2 here. Again, not sure if this is really going to address that, but it definitely needs to be fixed. Okay. Oh, good. Good, 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 good. There we go. There we go. They're coming out of the fiblage, only 4 at a time. They're stopping at the right time. They are not going into the ground. This is good. So while I am... okay. So I'm doing my own shooting. Remember, all the hit detection is off, so it's okay that bullets are going through everything. But it looks like whatever I added for the Fibla erasing of the bullets somehow found its way into the car's erasing of the bullets. This is going to be easy. This is not a problem, folks. Okay, I think I figured it out. This is the old code, and I had some temporary code to skip over all of the hit detection. But the point after the hit detection code is done, it is assumed that the D register has that value in it. So a code later that relied on the offset of the bullet info being in D was surprised to see that it wasn't there. So the fix is to make sure I do that load before my temporary code that skips over all the hit detection. Okay, that's still okay. And if I shoot, there we go. There we go. Okay. Okay. All right, I think it is time to add the hit detection back so that we can get those Fiblas exploding again and the car in actual danger. And then that will help me to try to tune things to see like what threshold should I really be using for the probability for the Fiblas to shoot. What is actually playable? Okay, I've re-enabled the old code so that we would have hit detection when shooting the Fiblas. And then I added some new code for hit detection when the bullet comes down to the car. So in the bullet loop, we take a look at the type and we ask if the bullet's coming from the enemy. And if so, we're going to go to this new portion. Otherwise, we have all this old code that checked when the Fiblas are getting hit. The new code for the enemy to car hit detection is very similar. And I'm using the same exact techniques that I showed in this video. I separately saved the row and the column for the car now, which I hadn't been doing before. And I'm separately saving the row and the column for each bullet, which I have been doing before. And I do these comparisons checking for a miss, and only if I remain in this code do I know that that's a hit. So for example, I ask if the bottom of the car is above the bullet. If so, we know it's a miss. And I check if the top of the car is below the bullet, in which case we know it's a miss. And similarly for the horizontal. And if we know we have a hit, I have this area in memory that tells me that the car needs to crash. And so the next time around in the loop, it'll do that crash animation. Okay, there we go. There we go. I'm going to try like moving the... Yep. Moving the car around, I can jump now. This is not on auto. This is very hard. This is really hard. So certainly having them do 4 bullets at a time is unplayable. by someone like me anyway. Let's make sure when I shoot, if I can ever get a bullet out. I'd like to see if I could shoot the Fiblas. Can I even? Oh my goodness. This is definitely in need of tuning. Oh my gosh. I can't. There we go. I got some of them. All right. And that what's good is that they actually are exploding. That's great. Oh my gosh. Ugh. So the first bit of tuning is I'm going to have the enemy bullets go down only by 1 row at a time instead of 2. So the car gets an advantage, it gets faster bullets. So this required changing the full offset, it required changing just the row byte itself. And in a bit of irony, I need to change the initial value of remaining travel by not dividing by 2, because the bullet goes down now only by 1 row at a time instead of 2. So that crazy bug I had before, where I wasn't dividing by 2 properly, doesn't even matter anymore. I'm not dividing by 2 at all. But whatever. And finally, I'm going all the way to the opposite end of the spectrum here. Rather than having the Fibla always shoot, I'm having the Fibla almost never shoot. So now only if the value returned is either 1 or 0 is it going to shoot. Okay, all right, barely ever, oops. Even like this, it's still hard for me. All right. Something a little bit off here is it's always doing 2 bullets at a time. Start shooting these. You see how, like, when it's finally time for a bullet to be fired, it's 2 bullets that get shot? What? Why is it always doing 2 at a time? Is it always 2 at a time? Well, I had a suspicion, and it turned out to be right. This simple Eeyore random number generator is a bit problematic here. If I let it fly and make it stop once it hits the number 1, you'll see that's very much toward the end of the sequence. Everyone has had a chance to increment up to C before offset 1 got a chance to update to C. Once we choose 1, the algorithm keeps shifting left. It keeps multiplying by 2. It keeps doubling. So it doesn't take long before, boom, it hits 0. And that same pattern obviously will repeat itself again. Once it hits 1, it just keeps doubling, 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 doubling until it hits 0 again. So 1 and 0 are always chosen in close proximity to each other. What do I do about this? Well, a very simple approach is just to reverse how this thing gets used. Rather than asking whether the random number is smaller than this, I can ask if the number is bigger. And I can just change this to be a big number rather than a small number. Effectively the same thing. We're only going to fire a bullet if we pick 254 or 255. And so I flip this around to a branch on low to skip it. Otherwise, if we got a random number higher than or equal to this, then we will go ahead and add a new bullet. So I just reversed a couple things, hoping that numbers on the high end of random Eeyore do not get chosen right next to each other like those 2 numbers on the low end. 1 bullet. This is so hard, man. 1 bullet. 1 bullet. That's good. Oh boy. I'm not used to playing this with hit detection on. No. Okay, the game is working. I am not. That's okay. So now that that seems to be working, I'd like to start tuning things so it's a bit easier for me. And one of the things I've been thinking is that when the Fiblas are at their lowest position, I don't have much time to react when they drop a bullet. So what I'd like to do is restrict it so that they can only drop bullets when they're at the highest part of their travel. So before I call the random number generator to decide if the Fibla should fire, I have some checks above it that decide whether it's even legal for the feedlot to fire. So I added this here, which takes a look at its row byte, which is kind of interesting. I only added this for hit detection, but now that I have it, it's kind of useful to use for this purpose too. So I just look at the row byte and I ask if it's at the highest point. And if it's not, then I go ahead and skip. Otherwise, I'll fall through and do the random byte. So here they are. They're not shooting. Okay, that's pretty good. Well, they didn't shoot at all. All I did is I added those 3 lines. Why would adding this cause that to happen? The only register I'm using is A, and I already trashed A here to check if there's any room for any new bullets. So why would using it here can't be the register? What? And there's nothing else that I did. I changed a comment, and I changed a branch to a jump, and then I added these 3 lines. What's going on? Something special about the register A. The emulator got horked. This new code somehow perturbed the timing to uncover a pre-existing issue. LWASM intentionally generating bugs to throw me into a tizzy. Well, the answer is, when I was loading A to decide if we had enough room for bullets, I wasn't just trashing A. I was preparing A for this Inca down below. This code runs if we decide to shoot a bullet, and then we use that to increment the memory location that stores how many enemy bullets are in play. So with the trashed A, I was storing a completely bogus value here, which would then cause me to read incorrect memory locations to find those bullet info structures. So my fix, I'm just going to use B. I wasn't using B for anything else anyway. And I was just about to trash B because that returns its value in B. So this is totally safe. And I also reduced this. We were getting very, very, very few bullets, so I wanted to get a slightly larger probability that we would have bullets going on. Okay. Huh, 2 bullets again. 2 bullets again? I'm getting 2, come on! Oh, how are we doing the 2 bullets again? I'm doing the high end of the high end of the range for the random number, but I increased the range by decreasing the threshold. So I guess I'm just getting, oh my god, again with the double bullets. Fine. So maybe it's time to just stop using random EOR, because no matter what I do, I eventually end up getting those double bullets. So instead, I'm going to use one of the random number generators that was in a close to a tie for second place in the Random Showdown video. And this is the one that Glenn uses in his Basic to 6809 compiler. But I took a look at the cycle counts. Random EOR is just taking 30 cycles. In fact, I don't even need to count these 2 for clearing out the A. So it's really just 28 cycles. Whereas Random Z is taking 61 minus those 2, so really 59 cycles. That is a lot more. And every cycle counts in a game like this. So I channeled my inner Simon Jonason, and I made a new version of this that just uses self-modifying code. In fact, he sent me the code that he used on Timberman, and it's quite similar to what I have here. I just made a few more tweaks and a few more immediate mode addressing changes. First, I renamed these random number seeds from seed1, seed2, randc, randx to just rs1, rs2, rs3, rs4. And instead of reserving memory for each of these seeds elsewhere, I'm using the code for the routine to be the storage for those seeds. So for example, when I want to store something into rs3, what I'm really doing is storing something into this label +1. So I'm going to store it here. The advantage of doing this is I get to use immediate mode addressing. So these 4 places that used to be extended mode are now going to be a lot quicker. And now when I take a look at the cycle counts, rather than being 61 minus the 2 for the clear A, it's 49 minus 2 for the clear A. And hopefully I won't be getting any of those repeating patterns causing things like double bullets anymore. And while I was at it, I flipped back to using numbers on the low end since it shouldn't matter if I do low or high, and I think this is just easier to read. So now we'll fire a bullet if we pick a random number between 0 and 5. So let's see how reasonable this is. So we've got to shoot... yeah, I turned off hit detection. Seems pretty reasonable. One at a time. Maybe we'll go into turbo mode and check out the bullet patterns, see if we see any double bullets. We advance further along. I guess it's kind of hard to see. I fixed all of these. Oh gosh. I don't like crashes that happen in a long time where you have to turn on turbo mode. What's going on? I didn't make any change here. The old get random byte only used the B register. The new get random byte only uses the B register, and then the B register is the register with the value that gets returned. If the same registers are used by both routines, and there's nothing else I did that could possibly cause a problem, did I always just have this problem and this is the first time I'm running turbo mode? Oh my gosh, this could be anything! What's going on? Something special about the register A. The emulator got horked. Some long-standing issue was uncovered by entering turbo mode, which allowed me to run through the code for many more cycles than usual. A bug with my precious self-modifying code. Well, it turned out that it was a very specific thing. At the end of get random byte, I'm clearing the A register because I took this from my random showdown code, where some random routines would return a 16-bit result and some would just return an 8-bit result, and the ones that return an 8-bit result I would deliberately clear out the A, which is the high byte, and I kept it in. So this is the same problem I had before. I was trashing my A register and then using that A register to update the bullet info counts. So we'll just remove that, thank you very much. Okay, one bullet. Wow, that's a lot of bullets at once. But not a pattern, that's good. Okay, time for turbo mode. Okay. Okay, I tweaked the playability a bit more. I made the Fibla bullets yellow and a bit thicker so you could see a distinction. I enabled the hit detection, crash detection, so if this is too hard for me, it will become obvious. Better not. Oh wait, did I not disable? There we go. I shouldn't have been able to land on that rock, right? Okay. Oh, okay. There we go. Oh, that's hard. Now keep in mind that I have everything up at once. Holes, rocks, Fiblas, bullets. This will not be the beginning of the game. The beginning of the game is going to kind of ease you into stuff. I see there's a blinking red... I'm not fixing that. Oh, it just disappeared. It fixed itself. I need to end this. This video is long enough.